When I was little, my father was famous. He was the greatest samurai in the empire. He cut off the heads of 131 lords. He was the greatest samurai in the empire. And he took me with him.
Hey everybody, thanks for tuning in. You've heard me say before that a major problem I have with flat earthers is that they only want to ask questions about the globe model and not answer questions about their flat earth fantasy. So a while back, I put up a video telling flat earthers to ask me questions since they like to do that so much. And I said I would answer them on camera. I got about 60 or so questions, and I'm going to answer 10 or so random ones here. And as I go through these, I want to give some more shout outs to donors to the Kickstarter, like Edward Winterberger, Bruce Naxon, and Fred Anthony Klein. You will find their information in the description. Let's get to these questions. Questions. Why did the Earth change from a sphere to a pear shape? Why are all of NASA's depictions of the Earth perfectly spherical? Why are there no pictures of an oblate spheroid? Okay. When Neil deGrasse Tyson said that the Earth was slightly pear-shaped, he was speaking in general terms. He wasn't saying that the Earth was actually shaped like the fruit. In fact, when you measure the Earth, it is not a perfect sphere. It's a little wider around the equator than it is over the poles, which makes it, by definition, an oblate spheroid. Now, people like to pull up images of an oblate spheroid and say, this is what the Earth is supposed to look like. Why do all the pictures look perfectly round? And this is an example of an oblate spheroid. True. But so is this. And this is a sphere. Now, Tyson mentioned the Earth being slightly pear-shaped because it is a little wider below the equator than it is above. Just a little. Like this one here. The difference is just so small that we can't tell just by looking at it. We need precise instruments. The question of when did it become pear-shaped? Well, given how little time people have been on this planet, I would hazard a guess and say that it has been that way all of our existence. We just didn't have the tools to measure it precisely enough until we sent the Vanguard 1 satellite up in 1958. Shout out to donors Mark Bobak, Systrike, and John Blankenship. Question, why has the size and shape and color of the continents varied so dramatically over the years? I've done a video on this topic that goes into how if you take a picture of an object far away, it will look flatter and more properly proportioned. But if you take a picture closer, the parts of the object in the foreground will be disproportionately big. As for color, this has to do with the cameras and the circumstance of the image being taken. Image sensors have different color gamuts. Different films process colors differently. And the same thing with scanners, they process colors differently. What I find interesting is that pretty much everyone knows this about cameras, and flat earthers excuse it for everything else except for images of the Earth. We see pictures of ourselves with different skin tones because of the camera or the lighting, and we say, my nose looks big in that shot, and that doesn't even look like me. But we never think that's fake. You say, oh, that camera was too close, or the exposure was too harsh, or that was a weird lens, but not that's fake. Why is that? A big thanks to Alessandro Bernardi, Sam Lehman, and Eagle Joe 8. Questions. If the moon orbits the Earth and the Earth orbits the sun, why does the sun not pull the moon off its orbit around the Earth? Also, if the sun is responsible for keeping the planets in orbit, why doesn't it draw Mercury and Venus into it? Now, we like to say that the moon is in orbit around the Earth because it's a simpler way to look at it, when in fact, the Earth and the moon are orbiting each other's common center of gravity, the barycenter, and they are both in orbit around the sun. The moon is in orbit around the sun just like the Earth, Venus, Mercury, and the other planets. And just like craft in orbit around the Earth, objects orbiting the sun are being drawn in toward the sun, but the velocity is such that it falls around the sun, basically missing the sun. The Earth is just making the moon do a little stutter step as it goes around. If it was left to its lonesome, it would follow a nice, smooth path around the sun. But the Earth keeps messing with it, making it kind of wobble like this as it goes around. I want to thank Gerhard Selig, Lee Premisberger, and Joseph Brzezinski. Let's see, question. If at 250 miles above the Earth, NASA claims that the gravity is 90%, what is Earth's gravity that holds the moon in orbit at 250,000 miles away? Wouldn't it be proportional at 500 miles, 80%, at 1,000 miles, 60%, at 2,500 miles, there should be no gravity felt from the Earth. Right? Even if it was for some odd reason not proportional, it makes no sense that the moon is held in orbit when the Earth's gravity effect dissipates as you get further away from the Earth. That was that question. And they're pretty good questions. So no, it's not proportional to the numbers that you were using, this person who asked the question. 250 miles above the surface of the Earth is 4,209 miles from the center of the Earth, which is where we begin the measurements for gravity. The surface of the Earth is 3,959 miles from the center, give or take a few. Now, gravity's strength is governed by the inverse square rule. So if an object is twice as far away, the strength of gravity drops to 1/4. 250 miles up is about 1.06 times further away from the center of the surface, than the surface. So square that and then invert it. Evening. You square that and then invert it, and you get a little more than 88% of gravity. So when you get to 2,500 miles, the gravity is 41%. So continuing with your other questions, if the moon is 250,000 miles away, what is the gravity then? And if it's such a small percentage, why is the moon still there? Okay. Well, at that distance, the Earth's influence is about 0.025% of what it is on the surface of the Earth, 1/40th of a percent. Now that's pretty small. But you have to remember, we're not talking about 1/40th of a percent of the pull that it would have on you or me. This is 1/40th of a percent of what it would have on the moon compared to if the moon were ever right up to the surface of the Earth. If the moon were right up to the surface of the Earth, the force between them would be insanely huge. So even when way out there, 1/40th of 1% is still big between them. Shout out to Doug Ingram, David Cameo, and Squawking Dead. Question: if the ISS is in constant freefall because zero gravity was a common misconception per NASA, and has to run an engine boost every so often to put itself back into its 250-mile high orbit, how do the other satellites stay in orbit without any way of propelling themselves higher? Well, most of the man-made satellites actually have their own thrusters to keep them in orbit. But if a satellite does not have any thrusters, it has to be very well placed and at the right velocity in order to fulfill whatever mission it has before it actually decays. But even satellites with boosters will eventually run out of fuel, and eventually they will come down. Norm Green, Daryl Cohen, and Daniel Summerton were kind enough to donate. A big thank you to them. Question: if we are flying through space at 3 million miles per hour, or whatever speed it is, how can we know ahead of time when meteorites and meteor showers are coming? This seems like it would be impossible to predict if we are moving at millions of miles per hour. Okay, meteor showers are predictable because they are recurring. They happen in a cycle. We've passed through the field of meteors before, and we will again. Individual meteors hit us blindly all the time. But it has to be said that while we are traveling at a high rate of speed, we are not zipping fast relative to the system around us. It's like being a car in NASCAR. You're zooming along at 200 miles per hour or whatever speed those things go. And so is everyone else on the track within a few miles per hour of you. So relative to you, they are not moving that fast. So even though we're cruising along as a planet, everything else in our solar system is cruising along with us. Also, the distances between things is vast enough that it still takes a while to get to us. So if something's coming our way and we see it coming, it's far enough off that we can tell that it's coming. Thank you to Nick Hempsey, Matthew Verdier, and Kaj Framke. Okay, question. When I see the sun and the moon in the sky at the same time, which in the past year has been very often, my daughter will tell you, she's tired of me pointing it out to her, and knowing that my angle of view is not very wide, doesn't this mean that on the opposite side of the planet they can't see the sun or the moon? I mean, I get it that they are far away, but on any sphere, what you see on one side can't be seen on the other. It's simply a viewing angle that restricts that. And it is my understanding that the moon is seen at night time everywhere in the world. I've seen them both morning in the sky in morning, midday, and afternoon. Okay, so I'm not exactly sure where people got the idea that the moon is always visible at night and only visible at night. I'm going to blame Minecraft until proven otherwise. So no, the moon is visible in either the day or the night, or neither, depending on the phase of the moon. By the way, for a good part of today, we could see the sun and the moon at the same time. I wish I had thought about recording this earlier. It is now just past sunset, and as you can see, there's the moon there. Let's see if I can zoom in a little bit. So there's the moon there, and let me back up. There's the moon there, and the sun just set over there a little while ago, just like, I don't know, 15 minutes ago. So there's the moon there, and we could see the sun for the moon for a good portion of the day and the sun at the same time, and that is because of the particular phase of the moon. And look at how the sun, the direction of the light on the moon there, it is right where it should be if the sun is in the distance way over there. Shout out to Paul Alexandrov, Paul Barrett, and Delboy 1967. Let's see, if we're on a globe that's tilted on its axis, which sounds fishy itself, what axis? Is there an up and down in space? Spinning at 1,000 miles per hour, rotating around the sun at over 500,000 miles per hour, in a galaxy, Milky Way, traveling over 1,000,000 miles per hour. How is it that we see the same stars every night? Same positions in the sky? How? Also, how come we see the same constellations over centuries if the Earth is spinning around the sun that's orbiting through the universe? Shouldn't the constellations change, or our perspective on them? Let's see, the Earth's axis is an imaginary line that it rotates around. There is no actual axis. If I spin a ball, the axis is the imaginary line that goes through it, passing through the points of rotation at the top and the bottom, at the opposite ends. The stars do change over thousands of years. 2,000 years ago, the pole star was not Polaris, it was Thuban. Astronomers today will tell you that comparing what they see today to what astronomers in the past observed and noted, many stars have shifted their positions within the constellations. Now you may want to disregard what astronomers say because you think that they are lying, but then you can't talk about the positions that they are in long ago, because it was the astronomers making the measurements then too. I'd like to thank Lori Letiajo, Jay Brown, and Labman Me. Question: if the Earth is round, when flying in the southern hemisphere, why do you need to travel north instead of going in a straight line? Why can't you fly from South Africa to Australia without stopping in the Middle East? Why would you even go to the Middle East? Okay, to answer the first part of this question, you don't have to go to the Middle East between Australia and South Africa. There are direct flights. Here's one here. It took 30 seconds to find that, by the way. What you seem to be caught up in, though, is the economics of commercial aviation. You have to fly where the money is. If an airline will only fill a third of a plane on a direct flight, but will fill 95% of a plane if it stops in the Middle East, drops off travelers, picks up more, and then heads on to the next stop, it goes where the money is. The follow-up question this person had was, how many miles from South Africa to Australia? How many miles from San Francisco to Singapore? There's a Singapore to San Francisco non-stop flight, but there's none from South Africa to Australia. Explain this. Well, the reason they asked this question is because on an AE map, San Francisco and Singapore are much closer than, say, Sydney and Johannesburg on the flat Earth map. But on a globe, and thus in the real world, it's about 13,400 kilometers from San Francisco to Singapore, and about 11,000 kilometers between Sydney and Johannesburg. That's over 2,000 kilometers closer. And there are non-stop flights between both sets of cities. Thank you to Renee Christensen, The Scattered Man, and Douglas Webb. Another question. If the sun is 93 million miles away, how can we see clouds behind the sun? You can't. That's just a very bright sun washing out the thin clouds between the sun and the viewer, and the thicker clouds not getting washed out, and thus you have a layer that looks like it goes behind. Now, for you flat earthers that think that those clouds are actually behind the sun, that means you think that the sun is at the same level or lower than the clouds. And planes and high altitude balloons go higher than the highest clouds, which means you think that planes and high altitude balloons can fly higher than the sun, which follows that high altitude balloons should be able to fly over the sun. Why doesn't any flat earther try that? Now, I get it that a hot air balloon doesn't have, or a high altitude balloon doesn't have propulsion, but if you get up there early enough, you can just get up there and let it pass under you, right? Of course not. That's because the sun is not low enough for the clouds to be behind the sun. Lastly, big thanks to Joseph Curtis and the people of Earth. This last question was prefaced with the statement, "This is the best flat Earth question I've seen." That's what they said. And then they continued with, if the Earth makes a complete rotation in 24 hours, it would be facing in the same direction at 12 p.m. no matter where it is in relation to the sun. How is it possible to have sunlight at 12 p.m. in every season? So first, let me clarify what that question is asking. Someone else asked this question and they used coffee cups as an example, and I thought it was a nice visual, so I'll do the same thing here. I did it during dinner with some friends of mine standing by. I showed them what the question was and my answer. So the basic premise is this. The question is, if this is the sun and this is the Earth, and at say high noon, the Earth is pointing directly toward the sun. And in 24 hours, the Earth makes a full rotation, puts it back here, okay? So the question is, every day, it should rotate 24 hours and back here. So after one day, it's here, rotates completely, and now it's pointing that way. After 2 days, it's here, rotates completely, and it's that way. After 3 months, it would be here, rotating completely, and being that way. This is still, technically, 24 hours later, that's high, that would be noon still. So by a year, it should be all the way on the other side, rotating all the way around, and then pointing that way. That would still be noon. But that's not how things work. So the question is, if it's really that way, why does it work this way? And the reason is this. The way we measure a day is not by the Earth rotating 360 degrees. We measure a day from high noon, when it's facing the sun straight up and down, to when it's facing the sun straight up and down again. So 24 hours is, move over here, you go around 360 degrees, and a little bit more. So it's facing the sun. That is actually what the Earth does in 24 hours. It goes a little bit more, turns 360 degrees. That's at about 23 hours and 56 minutes. And it takes another 4 minutes to point back to the sun. So after 3 months, it's here. It rotates 360 degrees in 23 hours and 56 minutes, and then rotates a little bit more, 24 hours. So what happens is every day it goes a little bit more, goes its 360, and then a little bit more, that's 24 hours. So when you get to the end of the year, here you are, you turn 360 degrees, a little bit more, and that's high noon. And that is why, after 24 hours, high noon is still straight up, and after 6 months, noon is still with the sun high and not facing the other direction. Because a solar day is more than 360 degrees.
That's it for this round of questions. I have said it before that every claim against the globe model that flat earthers put forth is based in their ignorance of the globe model, their ignorance of math, or their ignorance of physics. And so far, the questions I've gotten to this date have done nothing to change that impression.
That's my job! That's what I do! I don't lose! I win! Is there no one on this planet to even challenge me?
Maybe you came by to congratulate me on last night's victory.